So first video title is write the title.
Sir, wait.
First video title is
What is introduction about astronomy?
Introduction.
The study of the universe. Okay. First one is the study of universe.
No,
what
no,
about
no, no,
introduction
no, no.
about astronomy?
That's a chapter title. No need
Okay.
of that one. Just put the video. First video's title is the study of universe. Watch
Okay.
the video and write the summary after that.
Video title is
The study of universe.
The Study of
Yari
Universe.
bunny ko astronomy.
चुप हो जा.
Listen the voice also.
You turn off the lights.
क्या सिनेमा बनाना?
ये नजर नहीं आ रहा यार सही.
So turn off the lights, please.
Yes. Shh.
Creepy.
Getting more food.
It's late June, and summer is in full swing. In a small Northern California foothill community at the base of Mount Lassen is an abandoned airstrip that has been invaded by nearly 1,000 individuals of all ages. The purpose of their gathering is a mixture of science and fellowship, of sight and thought. These visitors will spend the next 5 nights scanning the sky with their telescopes, seeking out fuzzy patches of light to capture on cameras for in their mind's eye. This is the Shingletown Star Party, a gathering of amateur astronomers from the Pacific Northwest and beyond. And they are preparing for a dark sky experience.
Where you get away from the city where you have light
Can you hear?
pollution.
It's not clear.
Almost not clear.
Where you can see the sky at its best.
Just being out under a night sky, that's a relaxing, mind-expanding experience. There's a lot of beauty. There's just be able to look up and get a sense of how our lives relate to the universe as a whole.
If you're curious, you're drawn in and want to know more about what it is you're seeing and doing, and to find out about people like Kepler and Copernicus.
Covers.
You hear about terms, black hole, and then you find out that somebody thought up the idea of a black hole 250 years ago. What?
Say what?
250 years ago, and up until just 20 years ago, it was a theory. It was a fact. But here somebody had thought about it 250 years ago. It blows your mind. So you read about stuff like that, and you become more and more engrossed in not only astronomy, but all the fields that surround astronomy.
These amateur astronomers and millions of others like them around the world find enjoyment in the heavens that humankind has been gazing upon for thousands of years. Looking, watching, and wondering, what is the universe and how did it come about? This is the study of astronomy.
In our modern world, we're really isolated from the sky. We tend to go inside. The sun goes down. We have lights. We have television. We don't really notice the night sky. But not too many generations ago, people didn't have those conveniences. When it got dark, they looked at the sky. They watched the cycle of the moon. They watched the cycle of the sun rising further and further north and further and further south. They watched the cycle of the seasons. It was all connected to the sky.
Thousands of years ago, when humans stopped being nomadic and started actually turning to agriculture for food, they needed to know when to plant, and it became pretty clear that the seasons were tied to things that were happening in the sky. So it became really obvious that to understand how to grow your plants, you had to understand
of the birth of astronomy as a science So astronomy as a science is all about the universe. It's everything. And it's essentially boils down to three questions. What is around us? That's question one. Question two is, where did it all come from? And the third key question is, what is the ultimate fate of the universe? That's essentially what astronomy boils down to.
Astronomy can be broken down into broad areas of study. One area of study is planetary science, the study of planets, small, non-luminous bodies that orbit stars. A star is an enormous gaseous body that produces its own energy and light by nuclear fusion. The Earth is a planet that orbits our star, the Sun. Planetary scientists also study the processes that form planets and other smaller bodies like asteroids and comets. Together, a star and its planets form a solar system. A solar system consists of a host star, planets, moons, and minor bodies like comets and asteroids. And since the late 1990s, astronomers have discovered over 100 other stars, besides our own, that are orbited by at least one planet. Planetary science borrows from almost all the sciences, including biology.
Astronomy is rather unique in that it incorporates a lot of different sciences, including physics, chemistry, mathematics, biology now, since other planets are now considered worlds. There's a new discipline called astrobiology.
Astrobiologists are struggling to understand what life is and what conditions must exist on a planet so that living things can survive there. But scientists do know that energy is needed to sustain life, so the study of our sun's energy output is important. Solar astronomers observe our sun as sort of a laboratory specimen, noting changes on the surface and using them as clues to understanding the activity in the deep core. Stellar astronomers then take this data and compare it to other stars they observe to help define the family of stars that exist in our galaxy. A galaxy is a vast and enormous collection of stars and dust orbiting a common center of mass. Galaxies come in a variety of shapes and sizes, made up of a few billion to hundreds of billions of stars. Each one of these areas of astronomical study requires scientists to deal with the unimaginably large. A virtual tour of our solar system, galaxy, and the universe beyond will help establish a sense of the vastness and beauty of the cosmos. La Luna, Artemis, Selena, the Moon. It has been given many names in the history of humankind. It measures almost the distance between San Francisco to New York City. It is the nearest astronomical body to the Earth, and the only one that humans have walked on. Between 1969 and 1973, 12 astronauts accomplished the goal that many throughout history said couldn't be achieved. One of the reasons the feat was thought unattainable was the distance a Voyager would have to travel to reach the Moon. The average distance from the Earth to the Moon is equal to 20 times around the Earth. If you could jump in your car and drive 60 or so miles an hour non-stop, it would take nearly 5 months to get to the Moon. Although this seems far away from our earthbound perspective, it will quickly become apparent that this is a very minute distance compared to the size of our solar system, the galaxy, and ultimately the universe. A hop from our moon over to Venus, the next closest planet to Earth toward the Sun, is a mere 42 million kilometers at its closest to Earth. In a speeding automobile, it would take 48 years. When you got there, you would find a world slightly smaller than the Earth, wrapped in toxic clouds of sulfuric acid droplets high above the surface. Venus has an average surface temperature of over 800 degrees Fahrenheit, or 450 degrees Celsius, and provides a model for our understanding of global warming. Whipping around Venus and heading to the closest planet to the Sun, Mercury, our car trip would continue for another 56 years, for a total distance from the Earth of 91 million kilometers. Like our moon, Mercury bears thousands of impacts in it. We arrive at the Sun.
When you look at the universe as a whole, and you try to look at the substructures in the universe, you always wind up coming to
The sun is almost unimaginable. It represents over 99% of the mass of the solar system. Although it doesn't have a solid surface, the outer gaseous layers have a diameter that is equal to 109 Earths, strung out in a line. Our fictitious car trip would take a total trip time of 171 years, or a distance of 150 million kilometers, to go from the Earth to the sun.
One of the ways of dealing with astronomical distances that are just so big you can't imagine them if you express them in miles or kilometers, is to invent a new unit. One of the units that astronomers use is the astronomical unit. It's the average distance from the Earth to the sun. Astronomers use that astronomical unit to express the distance to things in our solar systems.
Armed with this new unit of measurement, our tour continues to Mars, the fourth planet from the sun and the last inner solar system planet. The fourth smallest planet in the solar system, Mars features some of the most spectacular geological features, the highest volcano and the deepest canyon. Mars is a treasure trove for geologists seeking to derive its history through remote exploration with unmanned vehicles. Mars is a little over 1.5 astronomical units from the sun. At this distance, the sun's rays heat the planet to an average temperature of minus 58 degrees Fahrenheit. As we transit to the next planet on our tour, we pass through a region of space debris called the asteroid belt. Rock bodies tumble and orbit the sun in this region, some large enough to see in a backyard telescope. Speeding through this region, we arrive at the largest planet in our solar system, Jupiter, with a volume that could hold all of the planets of the solar system and still have room left over. Jupiter is 5.5 astronomical units from the sun and host to dozens of moons, 4 of which can be easily viewed with a small amateur telescope. The average temperature of Jupiter is slightly higher than Mars, due to internal heating deep beneath its thick layers of clouds. This heating creates eddies and swirls in the upper cloud layers that garnish the planet like a holiday ornament. One such feature is the solar system's largest hurricane that 2 Earths could easily fit into. Jupiter, like the massive planets that follow, is called a gas giant due to its composition of hydrogen and helium. Jupiter has no solid surface like the inner solar system planets. Sunlight here is only 4% as intense as that which reaches Earth. Swinging past Jupiter, the journey continues to the ringed planet, Saturn.
As you study astronomy, don't miss a chance to see Saturn through a telescope. It's amazing. It's beautiful. Saturn has a beautiful ring of ice particles around it, and when you see it through a telescope, it looks totally unreal. It's the sight in astronomy you don't want to miss.
From this point in the solar system, nearly 10 astronomical units from the sun, sunlight has diminished to less than 1% of that received on Earth. Moving onward, the next outer planet is Uranus, at over 19 astronomical units. Uranus was the first planet to be discovered using a telescope in the late 1700s, and extended the known planets at the time to a total of 6. Math would play the key role in the discovery of the next planet on the tour, Neptune. 2 mathematicians independently calculated the position of Neptune due to its gravitational influence on Uranus. This blue-colored planet was first seen in a telescope in 1846. Speeding into the darkness of the outer solar system, we reach the frozen body known as Pluto. At nearly 40 astronomical units, the sunlight that reaches out to this small sphere is just 1/20% of what we enjoy on Earth. The average temperature hovers at a minus 380 degrees Fahrenheit. At an average 5.8 billion kilometers, or 40 astronomical units, the distance from Earth to Pluto would require an imaginary car trip of nearly 7,000 years. And yet, Pluto is only one small road marker on the journey to the outer reaches of our solar system. Beyond it lie other frozen bodies of rock and ice, some as large as planets. This is the icy realm of comets. the edge of our solar system is estimated at over 4 trillion kilometers from the sun. But as we depart the solar system, filled with planets of rock and gases, we will find that the distance to journey to the next nearest star requires another scale of measurement and the ability to imagine even greater distances. Most of us have experienced the sight of the Milky Way, that bright band of light that arcs across the sky. If seen from a dark location away from bright city lights, the memory will stay with you your whole life.
Occasionally we get good skies in England. The problem is partly the light pollution, partly the weather, very much the weather in England. I'd forgotten what the Milky Way looked like. I hadn't seen that since I was a child. We were at a place in northern New Mexico, and it started to come up, and we said to each other, it's clouding over, you know, because it just looked like clouds coming up. And then we realised, no, it wasn't clouds coming up, it's the Milky Way. And that's just incredible. We were looking at it last night, and you just see like a patch of cloud. But when you put the telescope on it, you see millions and millions of stars, and it's absolutely wonderful.
We live primarily in well-lit, very bright, very urban environments where you can't see the night sky. I'm sure that there are tons of people out there who've never seen the Milky Way galaxy. And once you actually see it and appreciate exactly what it is, it's breathtaking. It's amazing.
The Milky Strip we see in the sky is the side view of the Milky Way galaxy, our much bigger home in the universe. To comprehend the size of the Milky Way galaxy will require us to use another measurement established to deal with the distances too large for the astronomical unit.
The light year is a basic unit of astronomy. It's the distance that light travels in 1 year. Light travels at 186,000 miles per second, or about 300,000 kilometers per second. So the distance it travels over a year is 5.88 trillion miles, a very large distance, and again, something that's difficult to comprehend. So we break it down to one unit that we call a light year, and that allows us to express things like the distances between the stars in a number that we can imagine or manage.
One of the most common misconceptions in astronomy, and there are a lot, but one of the most common ones, is the idea that a light year is a unit of time, and it's not. It's a unit of distance. Very simply defined, it's the distance a beam of light will travel in a year. About 10 trillion kilometers. That's a light year. It's not a time at all.
After our Sun, the next nearest star is Proxima Centauri, at 4.2 light years, or 42 trillion kilometers away. As we continue through the galaxy, we will change our vehicle to one of imagination, which is capable of traveling hundreds of light years per second to allow this journey. Our journey of the Milky Way begins toward a dusty patch in the galaxy called the Orion Nebula. As we travel, we see the Milky Way is filled with stars. They glow not as a single star, but as a dense cloud of light.
If you look at a picture of a galaxy,